Hello. In this video, we're going to answer this question 6. So we have our function f of x equals -2 x minus 1 squared plus 5. So the first thing we identify is the parent function, and the parent function in this case is x squared. And we can see that because if we expanded this bracket, we would end up with an x squared term. That's the highest power. The vertex for this can be read directly off of vertex form, is going to be at 1, 5. And then we look at our direction of opening. Since there's a negative sign, it opens down. And then since this function opens down, it's going to have a maximum value at positive 5. And now we look at our axis of symmetry. Our axis of symmetry is always the x value of our vertex. So our axis of symmetry is at x equals 1, and this minimum should be y equals. And now we find our y-intercepts. Let's do that just up here. So to find the y-intercepts, we set x equal to 0 and solve for y. So we have y is equal to let's use proper function, f at 0. So the function evaluated at 0, or the y value when x is 0, is -2 times 0 minus 1 squared plus 5, which is -2 times -1 squared plus 5. -1 squared is 1. 1 times -2 is -2 plus 5, which is +3. So we have a y-intercept at 0, -3. Next we want to find our x-intercepts. But before doing that, we're going to do our quick sketch. The reason why we're going to do our quick sketch is it's going to help us get a picture of what this looks like, and that's going to help us decide how to go about finding the x-intercept. So in my quick sketch, I included a couple points. First point I include is the vertex. So the vertex is over 1 up 5. Remember, we really don't need a scale on this. It's just a quick picture of what this is going to look like. I'm going to include the y-intercept, which is 0, 3, which is right there. And I'm going to make sure I dot in this axis of symmetry, which is going to go through the vertex. And now I just roughly sketch out my shape. And I confirm that this is correct because it opens down. I see my maximum is at 5. I have my correct y-intercept, which I should actually put in here. Oh, I made a mistake, didn't I? Here I put the y-intercept as -3, and the y-intercept is actually 3. The sketch saved me. Okay, so now, the next step. I look at this and I notice that there are in fact 2 x-intercepts. There's an x-intercept here, and an x-intercept here. Again, you want to try and draw as much information as you can out of this. It's kind of like detective work. And what I see in this case is that one x-intercept is going to be positive, and the other x-intercept is going to be negative. So when I'm done my work, I should end up with one positive x value and one negative x value. So the x-intercepts are calculated by setting y to 0. So I take my function and I just set it equal to 0. So 0 equals -2 x minus 1 squared plus 5. So I end up with -5 is equal to -2 times x minus 1 squared. And then I end up with -5 over -2 equals x minus 1 squared. So that means 5 over 2 is equal to x minus 1 squared. So now I take the square root, remembering to take, when I take the square root, to incorporate both the positive and negative case. So therefore x is equal to 1 plus or minus the square root of 5 over 2. And the nice little check I have here is that, remember, we're thinking of the x-intercepts. We can think of if I'm at the line of symmetry, I'm going to move to the left some amount and move to the right some amount to get those two values. So this value here, I feel good because 1 is the x value of my vertex. And then root 5 over 2 is the distance that I move to the left and to the right sorry, to the left and to the right off the axis of symmetry. And if I wanted to, I could say that x is approximately equal to, so my result is the value of approximately 2.581. And everyone often says, how many decimals do we take it? And again, it's heavily context driven, but 3 decimals is usually a good final value. And then my other x-intercept is going to be 1 minus root 5 divided by 2. And it's a good thing to get your calculator out here and actually practice this. So x is approximately, make sure you have that approximate sign, 0.581. And at this point I can go back and check and say, does this make sense? And in fact it does, because we see that 1 is positive and is greater than 1, which makes sense based on this sketch. And 1 is negative and is just a little to the left of the y-axis, which makes sense. So I could say my x-intercepts here are, let's use a different color, shall we? My x-intercepts are going to be 2.581 and negative 0.5810. A good thing to ask yourself at this point is, when would I have no x-intercepts, and could I have just one x-intercept? In the next video, we're going to actually go through and graph this in a detailed manner. Good luck.